Hello everyone, in this video I'm gonna show you a SAP-1 architecture video, a complete implementation. In my previous video I showed a SAP-1 architecture that can load data manually, but in this video I'm gonna show you how we can do this automatically with the help of ROM and instruction loader. The only thing I added in this video is the instruction loader, which you can see right here. It has basically a counter, a 4-bit counter that counts from 0 to 16, which is needed to set the address, and a 1-bit counter. It is basically a D flip-flop that can toggle around 2 states. I can just show you right here. If I put this on and debug mode on, and with the help of clock pulse, you can see the counter is counting and the state is going from L1 to L2, and this is gonna happen right here. Okay, turning everything off, I'm gonna go to the main CPU right here, and I'm gonna show you how it works, how you can simulate this in your own PC as well. So first of all, what you need to do is put the instruction set in the ROM. So to do this, we need to know the opcode and the instruction code for this, and which is what I made right here. The binary address 0000, we're gonna put this instruction LDA 13, then LDA 14, add, store the value of this addition in address 15, and finally hold. And the two values we're gonna take is like the previous example, 51 and 25. So in this ROM we're gonna have to put the hexadecimal value, hex value. So we need to take the hex value of these codes, which is 1D, 2E, 30, 5F and F0, and the whole code is right here. So we can just upload the code in our ROM. We can just edit contents and then upload it. We can just put the values right here, or we can just upload it from a file which I have right here. So I can open this, and the code is now uploaded. Now what we can do is we can load this code into our RAM so that we can fetch, decode and execute this. To do this, to do the loading process, first we need to go to the loading mode, which is the debug mode of this pin. So we're gonna put this pin on. So our CPU is now in the debug mode, and we can see the LED has turned on. So first we need to do the PC reset so that we can reset the counter, and for each code to load on our address, we need to give 2 clock pulses. So first clock pulse will set the address of this RAM, and the second clock pulse will just put our ROM value into our RAM. So 2 clock pulses for each address, so we have total of 16 address. So it's gonna take 32 clock pulses. So I'm gonna start my clock pulse right now. You can see the data is loading into our RAM, and you can also see the data on the data bus, the second segment display of the data bus. Just now you saw that. Okay, we have done 32 clock pulses, and all the data from ROM is now loaded onto our RAM. So our data loading process is done. We can now just turn off the debug mode, and the CPU is now in the CPU mode state, which is the fetch, decode and execute state. So first we need to do the PC reset so that we can reset our counter, and now we can fetch, decode and execute it by the help of the clock pulses. It's exactly like before. We have total of 5 instructions. Each instruction takes 6 T steps, so in total we need to give 6 into 5, total 30 clock pulses to execute all the instructions. So I'm gonna start. After 5 clock pulses, we're gonna see the register 13 value into our register A, and after another 5 clock pulses, we're gonna see our address 14 value in our register B, and then we'll add this to number and store it into register A. You're gonna see a change, and then finally we'll store this register A value into our memory address 15. So I'm gonna start doing it. 4, 5. You can see the value of this memory address 13 is now stored in register A, and now we're gonna do the same for register B. You can see the value 19, hex value 19, which is stored in our memory address 14, now is now stored in register B. And now we're gonna add this two number and store in register A. So I have to give 6 more clock pulses. You can see the register A value changes. So now we have the addition stored in register A. Now another 5 clock pulses and we can store this value into our memory address 15. You can see our memory address, our register A value has been stored into memory address 15. Now we have to halt this. We need to give 3 more clock pulses to halt the program. You can see the counter value counts to 5. That means our 5th instruction has been successfully fetched, decoded and executed. So that's it. That's the whole video. You can always rewind this and do your own instruction and see each value of data bus, the counter value, the memory address register value, and also the instruction opcode value. You can see everything right here and do it on your own as well. Thank you everyone, thank you for your time, and finally we can do the PC reset and our CPU is good as new. Thank you everyone, thanks for the time.